The very next topic is design of stack height. So that is, we have already discussed about finding the effective height of stack, and after that, to find the design of stack height, that is the total height of the stack, we usually use empirical equations, and those empirical equations are related to maximum concentration of pollutants with the stack height, and also limiting the maximum concentrations to permissible values. Okay, so those empirical equations are based on maximum concentration of pollutants. So the empirical equations are given by the Central Board for Prevention and Control of Water Pollution, New Delhi, and they have regulated the minimum stack height for Indian conditions by based on these two equations. So out of these two equations, the maximum value has to be adopted. So the first equation is H is equal to 74 into QP raised to 0.27, where QP is the particulate matter emission in tons per hour, and the second equation is H is equal to 14 into QS raised to 1 by 3, where QS is sulfur dioxide emission in kilogram per hour. So basically, besides all the other pollutants, particulate matter and sulfur dioxide emissions are given due importance. Why? Because in majority of the industries, the emission rate of sulfur dioxide and particulate matter is much more compared to all the other pollutants. That is why the central board has used the particulate emission rate and the sulfur dioxide emission rate in their empirical equations. So for calculate the height based on these two formulas and then adopt the maximum value. And the board has further specified the minimum values based on the following conditions, that is, for chimneys adopted for industries other than thermal power plants, the height should be minimum 30 meter, and for thermal power plants, if the capacity is between 200 to 500 megawatt, then a height of 220 meter is required, minimum height. Then if it is having above 500 megawatt capacity, then 275 meter height is required. And the board has further provided provisions in case of chimneys of boilers and diesel generators. So in case of a boiler generating steam at the rate of less than 2 tons per hour, the minimum stack height should be 9 meter, and if it is at the rate of 30 tons per hour, then a minimum height of 30 meter is required, and if the capacity is in between these two values, then adopt a height in between 9 meter and 30 meter. And in case of diesel generator sets of different capacities, where kVA is the capacity of the diesel generators. kVA stands for kilovolt ampere. So the stack height is usually kept 1.5 to 3.5 meter more than the height of the building, and it is worked out by the equation capital H is equal to H dash plus 0.2 kVA, where kVA is again the capacity of the generator in kilovolt ampere. H dash is the height of the building. Okay, and capital H is the stack height. So to find the to design the height of the stack, two empirical equations have been given, and out of that value maximum has to be adopted, and there are certain other provisions that is given by the central board, that is in case of industries other than thermal power plants, and minimum of 30 meter is required. Then for thermal power plants, based on the capacity, the provisions are provided. Then for boilers and the diesel generator sets, based on their capacities, the height of the stack provisions are provided. So hope you understood this. Thank you.